Hi, I'm going to talk about the European Union's new framework for carbon removals. We've reached a point where simply reducing emissions isn't enough. We have to start physically pulling carbon out of the atmosphere to meet our climate goals. But how do we know if a ton of carbon removed by a machine or a farm is actually permanent, or if it's just creative accounting? On February 3rd, 2026, the European Commission took a massive step toward answering that question by adopting the world's first voluntary standard for certifying carbon removals. This legislation moves the EU from just talking about climate policy to creating a rigorous framework for technologies like direct air capture and biocar. In the next 5 minutes, I'm going to walk you through the scientific context of these technologies. More importantly, I'll explain how this event connects to our course concepts of material cycles and human disturbance, specifically looking at the friction between high tech policy and the reality of environmental science. These are the three pillars of CRCF. To understand why the EU legislation is such a big deal, we first have to understand the science of what is actually being certified. The Commission focuses on three primary methods: direct air capture, or DACCS, biogenic effluent capture, BioCCS, and biocar, BCR. The most high tech of these is direct air capture. Unlike traditional carbon capture that happens at a factory smokestack, DAC pulls CO2 directly out of the ambient air. There are two main ways we do this: solid DAC, which uses chemical filters at medium temperatures, and liquid DAC, which uses chemical solutions at very high temperatures, sometimes up to 900 degrees Celsius. But there's a challenge. Because CO2 in our atmosphere is so dilute, these machines have to process massive amounts of air, making the process incredibly energy intensive and extensive compared to other methods. This scientific reality is exactly why the EU needs a certification standard to ensure that the energy we use to capture this carbon doesn't outweigh the benefit of removing it. This is the module analysis. Under material cycles, the EU is trying to manage the carbon cycle by distinguishing between the permanence of different removal activities. While technical solutions like DACCS offer long term storage, nature based methods like soil carbon face risk of reversals, where carbon is accidentally released back into the atmosphere. Now let's talk about human disturbance. We are currently in a debate over how to fix the damage humans have caused. Groups like Carbon Market Watch warn that we must be careful with leakage, which is when human intervention in one area causes unintended emissions elsewhere. Because there is so much friction between policymakers and the scientific community regarding permanence, scientists use tools like conservatism factors to quantify and reduce uncertainty in environmental data. This event is a massive real world test of whether humans can successfully regulate and repair the global carbon cycle. And here's my bibliography. Thank you so much for listening to my presentation.